Today we're going to be talking about identifying functions. This is going to be a little bit review. So first, what is a function? In a function, we have two things. We have a domain and we have a range. If you remember back towards the beginning of the year, you'll remember the domain is all of the x values of a function. And the range is all of the y values of a function. For a group of numbers to be called a function, every x value has to only have one y value. It can't have more than one. So if you find an x number that has two y values that go with it, that set of numbers is not a function. If you look at the numbers on this xy chart, you'll see that the 2's have two different y values that go with them. That means that this would not be a function because the 2's have a 5 for a y value and a 6 for a y value. But if we made another chart, another xy chart, my y got a little away from me there. You can see on this xy chart, every x value has only one y value. The 0 goes with the 3, the 1 goes with the 4, the 2 goes with the 5, and the 3 goes with the 6. Each x value only has one y value. That's how we know that this is a function. Let's take a look at it graphically. If I have a graph of a function, it is going to look something like this. One line, and we can look from the left side of the function, the left of the x value, all the way to the right side, the far right side of our graph. As we move along that x-axis, every x point only has one y value. So this line would be considered a function. Now let's try and draw a function that would, or a line that would not be a function on a graph. If I drew a curved line like this in the shape of a C, this would not be a function. Let's look why. If I look at, say, x equals 1, at x equals 1, there are two different y values. There's a y value up at the top and a y value down at the bottom. That does not satisfy the rule we said that every x value has to have only one y value. So this would not be a function.